Have you ever wondered why the Challenger space shuttle exploded? It was a clear, cold morning on January 28, 1986, when the world was left in shock. The Challenger space shuttle, a marvel of human engineering, was reduced to a fireball in the sky just 73 seconds after takeoff. This catastrophic event was not just a blow to NASA, but it deeply affected the entire world. The Challenger disaster has left an indelible mark on the history of space exploration. It served as a stark reminder of the immense risks involved in venturing into the cosmos. The 7 brave astronauts on board who perished in the tragedy are forever etched in our memories as heroes who dared to reach for the stars. This event sparked a series of questions. How could such a disaster occur? Were there warning signs that were overlooked? So what exactly led to this tragic event? Let's unravel the story. The Challenger space shuttle was a marvel of engineering and human ambition. Born out of the space race, it was NASA's second orbiter to become operational, following Columbia. It was a symbol of technological prowess, designed to ferry humans and payloads to and from Earth's orbit. Challenger first took flight on April 4, 1983. It was a testament to the human spirit and our unending quest for knowledge and exploration. Over its lifetime, the shuttle completed 9 successful missions. It carried satellites, science labs, and even the first American woman and the first African American into space, breaking barriers and expanding horizons. The shuttle was the epitome of innovation, from its reusable solid rocket boosters to its ability to land like an airplane. It was a beacon of hope and progress, a testament to what we can achieve when we reach for the stars. However, its 10th mission would prove to be its last. January 28, 1986, started as a day of excitement and anticipation. The air was thick with a sense of adventure as the Challenger space shuttle was poised for launch at the Kennedy Space Center in Florida. A chill hung over the launch pad, a biting cold that was uncharacteristic for the Sunshine State. Despite concerns about the unusually frosty weather, the launch was given the green light. 7 brave souls, including a school teacher named Krista McAuliffe, the first civilian chosen for a space mission, were strapped into their seats, their hearts pounding with a mix of trepidation and thrill. Their families, friends, and countless spectators held their breath as they watched from afar, their eyes glued to the majestic spacecraft. Meanwhile, millions of viewers from around the globe were tuned in, their attention riveted to their television screens. The countdown began, the tension palpable. With each passing second, the anticipation grew, reaching a fever pitch as the final seconds ticked away. Ignition. The ground shook as the Challenger roared to life, a brilliant spectacle of human achievement soaring into the azure skies. The crowd erupted in cheers, their faces beaming with joy and pride. The Challenger was on its way, cutting a path through the frosty morning sky, carrying with it the hopes and dreams of a nation. Little did anyone know it was a countdown to catastrophe. Scene script. 73 seconds. That's all it took for the Challenger to turn from a symbol of hope to a symbol of tragedy. Imagine this. There in the sky, the Challenger was soaring, a beacon of humankind's ambition and technological prowess. And then, barely a minute into the flight, disaster struck. A plume of smoke, a bright flash, and the shuttle was no more. The spectators on the ground could only watch in disbelief as the unthinkable unfolded before their eyes. In those critical 73 seconds, the Challenger had reached a height of approximately 9 miles, traveling at nearly twice the speed of sound. Then, suddenly, an explosion. Not a bang, but more of a bloom. A fiery blossom of destruction that shattered the shuttle into 1,000,000 pieces, scattering them across the Atlantic Ocean. The spectators, families and friends of the crew, NASA officials, all watched in shock. The jubilant cheers turned into stunned silence, broken only by gasps of disbelief. The joyous anticipation of a successful launch was replaced with the horrifying reality of a catastrophic failure. The air was thick with grief and disbelief. 7 brave souls, including the first civilian to ever fly in space, had been lost. The world had been watching, expecting a routine launch, only to witness a nightmare. The shockwave of the explosion reverberated around the world, leaving a collective sense of loss and a burning question. What happened? The immediate aftermath was a flurry of activity. Emergency response teams were dispatched, and the mission control room turned into a hub of frantic efforts to understand the situation. The search for answers began almost immediately, even as the debris from the explosion rained down into the sea. The Challenger disaster was an unexpected blow to the space exploration program. It was a grim reminder of the risks involved in space travel, even as it pushed the boundaries of human knowledge and capabilities. The question on everyone's mind was, what went wrong? In the wake of the disaster, an investigation was launched to uncover the cause of the explosion. To solve this monumental puzzle, a special commission was formed, led by former Secretary of State William P. Rogers. With an array of experts on board, they began to piece together the sequence of events that led to the catastrophic end of the Challenger space shuttle. The commission discovered that the disaster was not the result of a single isolated failure. Rather, it was a combination of factors that, when put together, led to the fatal explosion. One of the key findings was the failure of the O-rings, a crucial component of the rocket boosters. These O-rings were designed to seal the joints of the solid rocket boosters, blocking hot gases from escaping and damaging other parts of the rocket. They were meant to be foolproof, but on that fateful day, they failed. The investigation revealed that the O-rings had become rigid due to the unusually cold weather on the day of the launch. The temperature was well below the threshold for which the O-rings were certified. They lost their elasticity, and consequently, their ability to seal the joints effectively. This allowed hot gases to escape, leading to the explosion of the fuel tank. But the cold weather and the O-rings were not the only culprits. The investigation also shed light on a critical flaw in the decision-making process. Despite the concerns raised by some engineers about the potential risks associated with the cold weather, the decision to proceed with the launch was made. The commission concluded that there was an over-reliance on past success and a lack of understanding of the potential for catastrophic failure. The explosion wasn't just a result of a technical flaw, but also a failure in decision-making. The story of the Challenger serves as a stark reminder of the immense responsibility that comes with space exploration and the constant need for vigilance, caution, and the willingness to listen, learn, and adapt. The Challenger disaster had far-reaching consequences. In the wake of the calamity, NASA was forced to re-evaluate its approach to safety. It was a painful wake-up call, one that led to significant changes in the space agency's safety measures. The Rogers Commission, appointed to investigate the disaster, found a combination of technical flaws and poor decision-making at the heart of the catastrophe. This prompted NASA to overhaul its management structure and processes. It established the Office of Safety, Reliability and Quality Assurance, an independent body tasked with ensuring that safety became an integral part of every decision and procedure. NASA also instituted rigorous checks and balances, creating a culture where engineers and technicians could voice their concerns without fear of retribution. The agency learned the hard way that ignoring even the smallest warning signs could lead to disaster. The importance of thorough inspections and tests was underscored, ensuring that every component, no matter how small or seemingly insignificant, was up to the task. The impact of the Challenger disaster wasn't limited to NASA. It sent shockwaves through the global space community, prompting other space agencies to re-examine their own safety protocols. The disaster served as a grim reminder that space exploration, for all its wonder and promise, was fraught with danger. It was a stark lesson in the importance of safety, one that resonated with every scientist, engineer, and astronaut across the globe. The Challenger disaster also had a profound impact on future space missions. The Shuttle program was grounded for nearly 3 years as NASA worked tirelessly to address the flaws that had led to the tragedy. When the Shuttle returned to flight in September of 1988, it did so with a renewed commitment to safety and a sober understanding of the risks involved. The lessons learned from the Challenger disaster continue to shape the course of space exploration. They serve as a reminder that every decision, every action, carries weight. They underscore the importance of rigorous testing, of listening to those on the ground, and of never allowing ambition to overshadow safety. The Challenger disaster serves as a stark reminder of the risks involved in space exploration and the importance of safety in every decision. It was a tragedy, a devastating loss of life, But in its aftermath, it forced a reckoning, a change in perspective, and ultimately, a commitment to doing better. It was a lesson hard learned, but one that has undoubtedly saved lives in the years since. And as we continue to reach for the stars, it's a lesson we must never forget.
Subscribe for more videos like this. Turn on notification and leave a like to help the channel out. Thank you for watching.